Okay, so the last video that I want to show you about is talking about a lot of vocabulary words, and it kind of continues on some other properties of water and compounds and so forth. So it's still kind of a chemistry review. All right, so two of your vocabulary words are adhesion and cohesion, and this just illustrates which one is which. Cohesion is when water molecules adhere to each other. So you're talking about water molecule adhering to another water molecule. And that's why you get this doming effect, which is really unique that they created this in this test tube. But it's water molecule on water molecule. If maybe you in elementary school or middle school, you actually did, you dropped like water droplets onto the top of a penny, and you were able to get the dome to form over the top before it spilled out. Or maybe you poured a beverage into a glass and you filled it so full to the top that you thought it was going to spill over, but somehow miraculously it held onto the rim of the glass. Well, that's what that is. That's cohesion. That's where the molecules are sticking to each other. Adhesion is where the water molecules adhere to something else, some other substance. Like in the case of this illustration, they're adhering to the sides of the test tube. And that's what causes the meniscus that we talk about when we read a graduated cylinder. Basically, the water molecules are climbing up the side of the glass because they're adhering to the side of the glass. That's what adhesion is. Okay. Next one, we're talking about solutions, and what is the solvent and the solute. Most of you probably heard this in physical science last year, but I want to review it. A solvent is what you are going to dissolve something in. Okay, a solute is what is being dissolved. So if you look at my illustration here, okay, here's my solution, and if you magnify it, the smaller gray particles are in much more abundance. Okay, so they are the solvent. The bigger red molecules are in less abundance, and they are the solute. So the red molecules are being dissolved in the gray molecules. So that's how you know a solute is dissolved in a solvent. Okay. Another concept that you want to be familiar with is a phrase that's called like dissolves like. And the way that you'll remember this is polar would dissolve in polar, nonpolar would dissolve in nonpolar, but a polar and a nonpolar will not dissolve. So that's where the like dissolve like come in. Polar and polar will dissolve, nonpolar and nonpolar, because they're likes, they're both the same. But if you put a polar and a nonpolar together, they will not dissolve. And the example is oil and water. I mean, you know that if you use salad dressing on your food and it's got a water and an oil component, it separates in the bottle, and you have to shake it before you put it on your salad, or you're not going to get a mixture because they won't mix together to form a solution. So that's like dissolves like theory, or concept, I should say. Another one is the pH scale. Just want to revisit the pH scale. You probably did it in physical science, but remember that you know an acid and you identify an acid and a base based on the hydrogen ion concentration. So if you look down here at my scale below, you can see that acids on this end have a high concentration. Every one of these bubbles down here, these little balls or whatever, are a hydrogen ion. So you can see acids have a high hydrogen concentration. Down here on the other end, where you're at the base perspective, okay, you see that there are not very many hydrogen ions. Okay, this is the same diagram, it's just on both sides of this sheet. So don't be confused thinking this one goes with bases and this one goes with acids. It's not. It's the exact same thing. These are the acids and these are the bases. Okay, and this is just a duplicate of that exact same illustration. Why it's on there twice, I don't know. Anyway, and you know that neutral is 7. So if you have a pH of 7, it's neutral. Water is usually neutral. Rainwater, which we'll talk about in ecology, is going to fall somewhere in a slightly acidic. And then, of course, acid rain, which we'll talk about in ecology, which is how it impacts our environment, is definitely stronger acid down here around 3 or 4. So basically, you just need to make sure that you remember that the pH scale is based on hydrogen ion concentration. Acids have a high concentration, and bases have a low concentration. And that's all the notes I have for you tonight. So we'll take that quiz tomorrow. All right, bye.